Hi, it's me! Did you know that the Nile River in Egypt is actually hiding some ancient secrets? Well, scientists may have just uncovered one of these secrets thanks to a supervolcano that erupted in Iceland. Wait, what? How does an Icelandic volcano relate to farming in ancient Egypt? Stick around. We'll get to that. But first, a word from our sponsor. Brilliant is a website and app built around active learning. You can trade boring lectures for problem-solving and interactive visuals. Brilliant is all about learning by doing. Start with a topic like algebra or programming and work your way through lessons and interactive exercises. Or pick a specific career track, like computer science or data science, and work through a customized set of lessons to learn everything you need to know. You can even take their placement tests to see where your skills lie. Brilliant has thousands of lessons and adds new ones every month, so whether you want to refresh your knowledge on a subject you've studied in school, or you want to finally understand calculus, Brilliant has something for you. And now back to ancient Egypt. It is no secret that humans rely heavily on plants, and without them we wouldn't have civilization as we know it. Agriculture was also central to ancient Egyptian civilization. Without plants like wheat and barley, they couldn't feed their population or sustain their livestock. Plus, the annual flooding of the Nile River that deposited nutrient-rich silt on fields made agriculture especially bountiful there. However, the details of how exactly they farmed remain a mystery in modern times. Archaeologists find it tricky to study farming. Because you untypically leave behind well-preserved physical remains like buildings or pottery. Their absence makes study and farming practices difficult unless we happen upon preserved plant remains or animal bones. And while these are useful, they don't always tell us much about the techniques people use to grow and harvest their crops. For example, if you found a chicken bone, you might know that the person who ate that chicken raised it for food, but that doesn't tell you much about how they farmed other crops or how well those crops grew. So, scientists are always looking for new ways to study farming, and recent research suggests that ancient Egyptian farmlands might preserve subtle clues in the soil itself. A team of researchers from the University of Vienna in Austria and the University of Cambridge in the UK say that volcanic ash from a huge eruption in Iceland 2,400 years ago could be the key to unlocking these secrets. You heard that right? An Icelandic volcano holds the key to Egyptian farming? Here's how the pieces fit together. The story begins in the year 735 BC when Mount Vesuvius in Italy erupted, blanketing parts of Europe and North Africa in ash. That wasn't unusual. Vesuvius is famous for its eruption in 79 AD that wiped out the Roman city of Pompeii. But this earlier eruption was more than twice as powerful. While Vesuvius was having a full-on tantrum, another volcano in Iceland known as Lakajigar erupted. This eruption was even more intense, releasing over 1,800 cubic kilometers of ash and pumice. The Icelandic volcano alone produced 10 times more ash than Vesuvius. Together, these two volcanoes unleashed enormous amounts of sulfur into the atmosphere. Sulfur reacts with water to form sulfuric acid, which then dissolves in rainwater, snow, and fog and falls back to Earth as acid rain. And the ash blocked out the sun, which together led to an ice age. According to the Intergovernmental Panel on Climate Change, global temperatures dropped by about 1 degree Celsius and lasted for several decades. In Iceland, the temperature dropped by an estimated 6 degrees Celsius. In southern Iceland, scientists found evidence of snow in the summer of the year following the eruption. But here's where the story takes a twist. After the initial fallout, a fine layer of ash covered large areas of Europe, Western Asia, and even Egypt. The team wanted to know whether this layer could be detected in Egyptian soils. To do so, they collected sediment samples from 5 different lake cores in Egypt. Now, each layer of sediment in a lake bed is like a ring on a tree. Each ring represents a year of deposition, and the bottom layers are older than the top layers. The team was able to use this dating method called varv dating to determine the age of the layers. They also used mass spectrometry to measure the amount of sulfur in each layer. Now, they were hoping to find a thin layer of ash at the beginning of the Ice Age. Just 1 summer's worth of deposition. The team expected to see a spike in sulfur levels directly corresponding to the year 735 BC. And indeed, they found an increase in sulfur levels in the sediments at the bottom of the lakes. But they were surprised to see that the spike lasted for 3 years, not just one. But why does it matter if the spike lasted longer than expected? It turns out that the team had some pretty clever deductions to make based on that detail. Let's go back to the issue of how farmers dealt with water. It is easy to imagine that the fluctuating water levels of the Nile would create a lot of challenges for farmers trying to plan their planting and harvesting. It is hard to know when to plant if you are unsure how much water there will be. And if you plant too early, the seeds could get washed away before they sprout. Farmers have been dealing with this problem ever since civilization began. Today, farmers in Egypt rely on the waters of the Nile. In the Aswan High Dam, a giant hydroelectric dam constructed across the Nile River in the 1960s, the dam helps regulate the river's flow and provides water for irrigation. Even so, changes in rainfall can still impact their yields. When there's less rainfall, the river's floodwaters contain fewer nutrients. This means farmers must rely more on artificial fertilizers. During heavy rainfall, though, farms can flood. Too much water can wash away the fertile topsoil and carry off the crops. Ancient Egyptians didn't have a high dam to manage the river's flow, so they developed clever ways to deal with the fluctuating water levels. For example, they dug canals to divert water to their fields, or built basins to hold water from the overflow. These methods are still used today. But just because we know these things happen doesn't necessarily tell us when farmers started using these techniques. One thing that can hint at the timing of these farming practices is sediment buildup in lake beds. If farmers were diverting water from the river, you'd expect to see lower sediment levels during the times when that water flowed to the fields instead of into the lakes. The team noticed a distinct drop in sediment after the big eruption, which they attribute to a change in farming techniques. Before the eruption, the sediment levels were high, indicating that the land was mostly natural, with little human interference. After the eruption, though, the sediment levels fell, suggesting that farmers were diverting water from the river. What's more, the 3-year gap between the ash layers tells us something about how long these farming practices persisted. After the eruption, the amount of water available to farmers would have varied widely. Some years there would be massive floods, followed by dry spells, and farmers would need to adapt. In fact, records from ancient China describe severe flooding in the years immediately following the eruption. The team thinks that the reduced sediment level reflects how farmers coped with these changing conditions. It seems like they relied on irrigation during the drier years, but reverted back to relying on the Nile's floods when the water levels were higher. This finding suggests that the effects of climate change weren't just limited to large-scale environmental shifts. On a smaller scale, the farming practices themselves changed in response to a rapidly shifting climate. Ultimately, this work shows that ancient Egyptians' farming practices were complex and sophisticated. It also demonstrates that small variations in climate can have wide-reaching impacts. And finally, it highlights the power of interdisciplinary research. By combining archaeology, geology, history, and climate science, we can uncover new insights into the world's history. It's a reminder that there's still so much to discover about the world around us. Who knows what secrets the soil is hiding? Perhaps one day we'll unearth even more fascinating details about ancient Egyptian farming. Thanks for watching this video.